Welcome back to the deep dive. So you gave us this stack of source material on cost accounting, and our job is to pull out what you can use, right away. Today, we are getting into what might be the single biggest headache in business forecasting: cost behavior.
It really is.
I mean, in a textbook, everything's so neat. Costs are either fixed, like your rent, or they're variable, like raw materials.
Right. Simple.
But reality is just not that clean. Most costs are what we call mixed costs. They're this blend, this middle ground, and that mix can absolutely kill your ability to budget or predict profits accurately.
It's a huge blind spot for a lot of companies.
Okay, so let's unpack this. Our mission here is to really distill why you have to separate these mixed costs for any kind of serious cost volume profit analysis. And then we're going to get into the trade-offs between the two fastest ways to do it: the simple high-low method versus the more visual scattergraph method.
And that separation is everything. It's the absolute foundation of planning. I mean, if you don't know what chunk of your cost is fixed and what chunk changes with activity,
You're just guessing.
you're completely guessing. You can't tell your boss how costs will react if you double production or if you have to scale back, knowing this is the only way to find your true break-even point.
Right.
But before we even get into the methods, we have to talk about a really critical concept from your sources: the relevant range.
Okay.
All of this estimation, everything we're about to discuss, it only works within a company's normal range of activity.
It's not a crystal ball.
Not at all. If you suddenly push production way outside what you've ever done before, your whole cost structure might change. So we have to keep that idea, the relevant range, in mind through this whole conversation.
That is a huge point. We're predicting costs for the business as it normally operates, not for some crazy future scenario.
Okay, so let's make mixed costs more concrete.
It's just two parts, right? A fixed part plus a variable part.
That's it.
And your sources has some great examples. Think about the electricity bill for a factory. You pay a fixed amount every month just to be connected to the grid,
Your base charge.
right? Your base charge, that's fixed. But then for every hour a machine is running, you're using more power, and that adds to the bill. That extra bit is your variable component.
And you see this pattern everywhere. Take a salesperson's compensation. They get a base salary. That's their fixed cost. It lets them pay their mortgage. But to motivate them, you add a commission. That's a variable cost tied directly to how much they sell. The salary plus the commission, that's a mixed cost.
So we agree on the problem. Mixed costs are everywhere, and they make it hard to see what's really going on with profitability.
So to separate them, you basically have three options.
Okay.
Option one is the gold standard: invoice-by-invoice analysis. You literally go through every single bill, every transaction, and categorize each part. It's incredibly accurate because you're using all the data.
But wait, who actually does that? I mean, in a real business, that sounds paralyzing. It would take forever.
Oh, it is. It's the benchmark, the ideal, but it's way too slow and expensive for making timely decisions. You need a whole team just for that.
So it's not practical.
Not really, which is why most managers turn to estimation. And that brings us to the two we're focused on today: the Scattergraph method, which is visual and uses all your data, and the high-low method, which is just a quick calculation using only 2 data points.
Two very different approaches.
Very. But no matter which one we pick, the goal is always the same. We need to create the cost equation.
Right.
The final result has to be total cost equals a fixed cost plus your variable cost per unit times your activity level. That little equation unlocks everything.
All right, let's start with the high-low method. This is the simple, fast, and, the objective one.
Yeah.
If you need an answer right now, this is probably where you'd go.
And that simplicity is its biggest appeal. The idea is that if the cost relationship is basically a straight line, you should be able to define that line by just looking at the 2 extreme points.
The highest and lowest points.
Exactly. But, and this is key, it's the highest and lowest points of activity, not necessarily cost. So using the factory electricity data from your sources, we look for the months with the highest and lowest direct labor hours.
Okay, so the high point was 18,000 hours, which cost $120,000. And the low was 6,000 hours, costing $60,000. And just to be clear, we are now actively ignoring all the other months of data.
We are. For this method, they don't exist. So next, we calculate the variable rate, which is just the slope of the line between those 2 points. It's the rise, the change in cost, over the run, the change in activity.
So the cost changed by $60,000 and the activity changed by 12,000 hours.
Right. You divide them.
Which gives us a variable cost of exactly $5 per hour. Nice and clean.
Very clean. And once you have that $5 rate, you can find the fixed cost. You just plug the numbers from either the high or the low point back into the total cost formula.
So let's use the high point. The total cost was $120,000.
Right.
We subtract the variable part, which is $5 times 18,000 hours.
Which is $90,000.
Right. So $120,000 minus $90,000 leaves you with a fixed cost of $30,000.
And there's your equation. Total cost equals $30,000 plus $5 times direct labor hours. Simple as that.
Okay, that was incredibly fast and objective. There's no guesswork. But here's where I get a little nervous. You're telling me we're going to base our entire budget on the two potentially weirdest months of the year.
That's the risk.
I mean, what if the high month had a huge one-time repair bill in it? Or the low month was slow because of a week-long holiday.
Yeah.
You're building your whole forecast on 2 points that might be total statistical outliers.
That is the perfect critique. It's the fundamental flaw of the high-low method. It's fast, it's objective, but it's blind to the context of all the other data. It can be dangerously misleading.
All right, so if high-low is fast but risky, let's look at the alternative, the Scattergraph method. This one tries to use all the data to avoid that outlier problem.
Exactly. The Scattergraph turns your numbers into a visual story, which for many people is just much more intuitive.
How does it work?
It's simple to set up. The horizontal axis, your x-axis, is always your activity level in this case, direct labor hours. The vertical y-axis is always the cost, your electricity cost. Then you just plot all 6 of your historical data points as dots on the graph. And right away, you can see things. You can see if the dots generally form a line or if one dot is way off by itself.
Ah, so you can visually spot an outlier that high-low would have just blindly used?
That's one of its biggest strengths. Once the points are plotted, the next step is to draw what we call a best fit line through the data.
You just eyeball it.
You eyeball it. You try to draw a straight line that goes through the middle of all the points, minimizing the average distance from the line to every single dot.
So it's more an art.
A little bit. And from that line, you can pull your 2 numbers. First, the fixed cost is just the y-intercept, where your line crosses the vertical axis at 0 activity. Looking at the graph in the sources, that line hits at about $40,000.
So that's our base cost.
That's your base cost. Then the variable cost is just the slope or the steepness of that line you drew. Based on the visual estimation, that slope comes out to about $4.29 per hour.
Okay, so the Scattergraph gives us a totally different equation. Total cost equals $40,000 plus $4.29 direct labor hours.
Right. And here's the trade-off. We gained the huge benefit of seeing and using all the data, which gives us more confidence that we're modeling a typical month. But we lost objectivity because you and I might draw that best fit line slightly differently. Your $4.29 might be my $4.35. It's objective.
So what does this actually mean for a manager? We used the exact same data and we got 2 completely different answers. One model says fixed costs are $30,000, the other says $40,000. That's a big gap.
It is. So let's make it real. Let's use both equations to predict our costs for a future month where we expect to have 10,000 direct labor hours of activity.
Okay, a level that's right in our relevant range but wasn't one of our original data points.
Exactly. So if we use the Scattergraph estimate, the one that used all the data, we take the $40,000 fixed cost and add $4.29 times 10,000 hours.
Which gives you $82,900.
Correct. Now let's try the high-low estimate. That's a $30,000 fixed cost plus $5 times 10,000 hours.
That's $80,000 even.
So we're $2,900 apart. Now, neither one is the absolute truth. They're both just estimates. But that gap shows you that the choice of method really, really matters.
So why should you care about a $2,900 difference on an $80,000 estimate? I mean, what's the big picture here?
Well, the big picture isn't just the total cost. It's the components. Look at the variable cost. One model says every hour of work costs you an extra $5. The other says it only costs you $4.29.
That's a 71-cent difference.
And that 71 cents is everything when you're making decisions. If you're using the $5 number to price a new custom job for a client, you might think your costs are too high and quote a price that's too high and you lose the business.
And you left profit on the table.
Pure profit. Or worse, if the true cost is $5 but you use the $4.29 number, you might underprice a huge contract and end up losing money on every single unit you produce. The variable rate drives your pricing and the fixed cost drives your budget. These 2 models give you very different tools for those 2 critical jobs.
So which one do you choose? How do you make that call?
It really boils down to the stakes of the decision. If you just need a quick and dirty number for an internal budget meeting, high-low is probably fine. It's fast.
But if the stakes are higher?
If you're setting the price for a multi-year contract that could make or break your company, you absolutely have to use a method that minimizes the risk of being skewed by an outlier. So you'd start with a scatter graph to see the data visually, or even better, use a statistical regression analysis, which is like a computerized version of the scatter graph that removes all the human subjectivity.
Okay, so a sanity check could be to run both methods.
That's the best practice. If both methods give you very similar answers, you can have a lot more confidence in your numbers. It probably means your high and low points weren't outliers after all.
But if they're far apart, like in our example,
That's a red flag. It's a signal to stop what you're doing and investigate your data more closely before you make any big decisions.
so to wrap this up, we've seen why you have to separate mixed costs to do any real planning. We've walked through the high-low method. It's simple, it's objective, but it's risky. And we've explored the scattergraph. It gives you context, it uses all your data, but it's subjective. The key is understanding those trade-offs.
Which brings up one final thought.
Yeah.
We kept talking about that relevant range, which for this data was between 6,000 and 18,000 hours.
Right.
So here's the question. What happens if the company gets a massive new contract and suddenly needs to run at, say, 30,000 direct labor hours a month? That's way outside the range. Does that fixed cost, that $30,000 or $40,000 base electricity charge, stay fixed? Or do you suddenly need a whole new factory, causing your fixed costs to jump up to a completely new level? And how would you even begin to budget for that?
That's something for you to mull or explore on your own. Thank you for taking this deep dive with us.